Okay, we're going to look at another chain rule example. So when we look at this problem, there's something else you should notice here is that besides just chain rule, you've got a quotient of two functions. So we're going to need to use quotient rule as well. So I've got chain rule written at the top here. I'm going to go ahead and write quotient rule over here. We learned that previously, so just as a little reminder. And I'm just going to use some short notation. Our textbook does this too, where instead of writing f of x and g of x, we'll just write f and g. All right, so derivative of a quotient of functions, f of x over g of x. We're going to start with the derivative of the top, so f prime times the bottom, g, minus the top times the derivative of the bottom, g prime, all over the bottom squared. Or there's little mnemonic devices you can remember, lows and highs and things like that. I posted some links to some videos about that. So however you remember quotient rule, as long as you can write it down correctly and use it, we're going to need that on this problem as well. Okay, so we're going to need quotient rule as the overall structure. So we're going to think through that. And then when we go to take the derivative of the denominator, that's where chain rule is going to come in. So I've got a function, the 2x cubed function, inside the exponential function here. So that's where my chain rule is going to come in. All right, so since we're going to be using two rules here, quotient rule and chain rule, my piece of advice would be to set up a structure for yourself and then fill in the pieces. So the overall structure of the problem is going to be quotient rule. So I'm going to set up some parentheses for that and some little labels here to help me remember what I'm doing. All right, so I usually start by taking the derivative of the top. That would be our f prime. So I'm just going to write der top, or you could write f prime, derivative of the top times the bottom minus the top times the derivative of the bottom. That's where we'll need chain rule. When I take the derivative of the bottom, that's where I have a function inside another function. And then the whole thing over the denominator squared. Okay, so this is your overall structure of quotient rule, or you can write it with f primes and g's, or however you want to do that, but thinking through that overall structure, and then going through and kind of just filling in the pieces here. All right, so the derivative of the top, that's my derivative of 5x cubed minus 1, so that's a pretty easy derivative, 15x squared. Then times the bottom, I'm just leaving the bottom alone, minus the top, leaving the top alone. And now times the derivative of the bottom. So this is where I will need to use chain rule. So on the denominator here, I have this 2x cubed function that is inside the exponential function. So the exponential function, e to a power of a variable function, is the outer function. Okay, so when I go to use chain rule to take the derivative of that denominator, I need to think about what we have for chain rule up here. Derivative of the outer function. Derivative of e to a power is just e to that power. That's that function that is its own derivative. And then times the derivative of what's inside that exponential function. So times the derivative of 2x cubed, we'll get 6x squared. That's where we used chain rule. And then the whole thing over the bottom squared, e to the 2x cubed, the quantity squared. Okay, we do have some simplifying we could do on this one. I'm going to remove some parentheses here, and I might do a little bit of canceling as well. One thing I might notice here on the numerator is that I have two giant terms, and I have some common factors in both of those terms. So I might go ahead and factor some things out, and then we can do some canceling with that. So in this first giant term, I have a 2x cubed, e to the 2x cubed, that I also have in this second term. And notice I have some of those in the denominator that I'll be able to cancel. There are also other common factors that I could choose to factor out if I want to. There's an x squared in both of those, and a factor of 3, a 3 in the 15 and in the 6. So if I wanted to also factor out the 3x cubed, I could do that. I'm going to go ahead and leave that in and just factor out the e to the 2x cubed. That is a common factor for both of those, so that I can cancel that with one of my exponential functions in the denominator here. Okay, so we have e to the 2x cubed. And then I'm left with 15x squared. And then on this last part here, I'll be left with a minus 5x cubed minus 1, that quantity, times 6x squared. I'm going to go ahead and distribute through the minus sign and the 6x squared at the same time. If that's too much to distribute through all at once, you can do that in a couple of separate steps. So I'll have the 5x cubed times the 6x squared will be 30x to the 5th. I'm distributing through this minus sign as well. And then the 6x squared times the minus 1 will be 6x squared, and I'm distributing through that minus sign as well. So we'll have a plus 6x squared. And then I could go ahead and simplify this exponent on the denominator if I want, but my goal here really is to cancel one of these factors of e to the 2x cubed on the denominator with the factor that I have on the numerator. So I'm not going to worry about simplifying that because my goal is to cancel one of them so that I'll be left with just one of those on the denominator. All right, I do have a couple of like terms I could go ahead and combine if I want to on the numerator now. 21x squared minus 30x to the 5th all over e to the 2x cubed. So there is a simplified version of our answer.